Let's say you made a new reporting database and you were wondering, the projections that are running my reporting database, if I had this reporting database 2 years ago, what would this reporting database have told me on the morning that this really, really awful thing happened? That when we discovered this, all these problems that were there, what would this new reporting database have told me back then? You could do this, correct? You just only replay the event stream up until that point in time for your new reporting database, and it would tell you this is what that reporting database would have had at that point in time. Remember, we're deterministic. There's lots of other cool things that you can do. Could I do what-if scenarios in my history? Could I find complex scenarios and whether or not they might have existed in my past? So I'm looking for a case where this guy overdrew his account by more than $500, then brought it back into a positive balance in less than 24 hours, and then brought it back below $500 again. How often did that happen? How would you do that with a SQL database? Don't get me wrong, if you had all the transactions actually put into a SQL database and then you treated them as events, you could actually do this. But if you're updating the data, you wouldn't be able to do this. Other really cool things. How many of you have released software before? Hopefully a few people. How many of you have rerun through every transaction your system has ever processed in the past as part of releasing software before you went live? Just to see what might have changed in the new version. Would that be hard to do if I had an event log? So if I save my commands, could I rerun through all of my commands on the last version of software, then rerun all my commands on the new version of software and show what the differences were from version A to version B? How valuable would that be? To have rerun every transaction your system has ever processed and shown that it produced equivalent or expected differences from version A to version B. No, this is not a smoke test. This is I reran every fucking transaction your system has ever done. Would you be confident having rerun every transaction your system has ever processed as your smoke test before you go to production on every release? You have to admit, it'd be kind of amazing to get a new one that broke it. There's lots of interesting things like this. Now, when we talk about a log with event sourcing, it's always an ordered sequence as we see above. But this is a somewhat naive viewpoint on things. And the reason why is that sometimes that log can get really, really big. Here we've got 7. What if this was 1.7 million? Replaying 1.7 million events might take a while, correct? If everything that we wanted to do, we had to replay 1.7 million events, it'd be a bit slow. But what if we were to start dropping in snapshots? And snapshots can be for domain objects, they can be for read models, they can be for any projection that comes off that event stream. So long as that projection does not change in how it produces state, in other words, it's immutable, I can snapshot anything it's ever done before. And by doing this, I can say this snapshot is at version 4. Therefore, you only need to play from this point forward in the log unless we have a change to the thing that produced the snapshot. Now, I've dealt a lot with looking at code from code. How hard would it be to calculate a hash of the projection by walking its dependencies to figure out whether or not it's actually changed? Let's just imagine it was in Java or C#. We could get right into the IO or bytecode, and we could look at the methods that are being called, and we could calculate a hash on it, correct? So then I would know whether or not I can still use the snapshot. In fact, all I need to do is put that, excuse my language here, that stupid fucking hash associated to the snapshot. It would work for all of my snapshots, correct? So long as I can calculate a hash of the code that produced it, I can say whether or not I can use it. It's that easy. As such, if you made a change to the thing that was actually producing the snapshot, I would automatically know to replay. My snapshots, you have to be very careful about this, are nothing but a heuristic. They're helping me replay faster. It's not that this is some core fundamental part of my system and I worry about versioning my snapshots from software version to software version. No, 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 screw all of that. Snapshots are temporal, they're throwaway. They're convenience. What I get in terms of state is always from replaying the full log. A snapshot just prevents me from having to replay the entire log. It gives me a little bit faster of a way of doing things. I'll just skip over that one. So now we've gotten through a bit about event sourcing. Let's talk a bit about CQRS. So there's one thing that really, really sucks about event sourcing. So you have this beautiful event log of all the events that have occurred in your system since beginning of time. How would you query for me all customers who have the first name of Adam?
You just read them all.
I guess we could replay every event in the system. Watching through name changes, we can even map reduce this. Do it across many, many servers, replaying every single customer until we reach the end of the stream and then reply back whether or not their name was Adam at the end of the stream. How many of you think this is a good way of looking up Adam's account when he goes to log in?
Well, if there's few events, then they'll be quick.
What if I'm looking for all Adams? Oh, crap. This is going to be hundreds of millions of events now, isn't it? What CQRS, which is thrown on now, basically does is it says instead of thinking about our domain like this, where we basically have a data storage, we have our domain model, and then we have reads and we have writes going to the same domain model on the same service. Because this would be really, really hard if you were event sourcing everything. So we say, okay, let's not do that. Instead, what we're going to do is we're going to have two services. It's not that hard. So our domain objects are just the way that they were before. The only thing that we've done is we've said that we're only going to write to them. They process commands. We then pull out a second service, which we call our thin read layer. Basically, it's a read service. It does all my queries back to my database here. Nothing more. So any query that returns a result goes on this side. Any action which does not return a result goes on this side. So we have behaviors on the left and we have queries on the right. And we're just taking our single service and we're breaking it apart into two services. And there's lots of reasons that we do this. It's not just because it actually turns out really, really well in the domain model. How many queries do you do for every transaction that you process? Are they one-to-one? Are they 5-to-1? Are they 10-to-1? Are they 100-to-1? It depends a lot on your system. I have seen where we actually have, in terms of things that we process, 1,000 or even 10,000 reads for every one write that we do. These two services have dramatically different scaling and availability stories associated to them. It actually makes a lot of sense to have them as two different services. And when we talk about them, we talk about our write side and our read side. And I've always had people take a piss out of me because the right side is on the left. But if you look, if you were to flip that, the diagram doesn't really make much sense, does it? The reason for this is if you watch how data flows through the system, it actually flows clockwise, which helps a lot with people understanding the concept of time in dealing with it. Now, in terms of read models, a single read model will never be appropriate for all of your reporting, searching, and transactional needs. Never. I don't care which model you pick, you're wrong. There will always be some things that you need to do that do not fit well with the model that you picked. Let's just see here. Okay, that one did. Yes. Our read models have a different perspective on data than our write models. Let's just try an example here. When I'm dealing with orders from a transactional perspective, I generally want to deal with one order at a time, correct? From a reporting spectrum perspective, do I generally want to deal with one order at a time? Or do I want to deal with aggregations of orders? Often I'm looking at 400,000 orders brought together in varying ways. The read model has a different perspective on my data. And this is probably the single biggest problem that you see with their standard third normal form database type system, is that they start trying to write their reports off of their third normal form model, and dear God, does this get complex. How many of you have written a nested subquery inside of a nested subquery, which was then joined to something? Hey, why not? You can do it, right? How does that query optimization work? Well, not quite sure on that one. But this concept that my reporting has a different perspective of my data is something that really leads you to the concept of CQRS in general. What my clients want to be working with, whether we're talking about screens that they see, whether we talk about reports that they view, is different than my model that I need for validating transactions. You can work in domain after domain after domain after domain, and you will find that once you have this single model concept out of your brain, that these two models diverge massively. They are nothing like each other. And this is a main benefit of CQRS. And it will very often allow you to come up with simpler models, because you're not thinking about both sides of the problem. A perfect example of this would be in my domain model. If there are things that I don't use in validation, why are they in my domain model? Customer's first name. If there's nothing that I actually validate off of a customer's first name, why the hell is that my domain model? You can remove it. It needs to be in my read model because we query that information. But if I don't have any validation associated to it, I don't need to have it in my domain model. My domain model is focused on validating transactions. It needs data to validate transactions. It does not need everything else associated with that data. Now, I've had this for quite some time. What about scalability? We mentioned that most of the things that your system does are queries. Could you just add more query services, more instances of query services? Could you add next to your instances of query services more instances of read models? My query side has become, although the concept doesn't truly exist, horizontally scalable. It's not purely horizontally scalable, but for what most people are considering, it's horizontally scalable. I just continue adding new read model and read service. But there's another benefit with it, aside from horizontally scaling. Could I geographically distribute? Could I have my write model living in New York City and my read models living in New York City, Vancouver, London, and Perth? Would that be hard? And remember, when we talk about distributing these read models, that pretty much all queries can operate with relaxed consistency. If this data takes 45 seconds to show up into Perth, and Perth was querying older information, we can still provide consistency on this. And the fact that they were seeing 30, 45-second old information is not the end of the world. If they're having a problem, I can detect their problem. But the huge number of queries that are being run, whether they are running on 5-second old data or 1-second old data, makes absolutely no difference to the person running the query. And this is a large number of these types of queries. And this can buy you a lot once you come to the realization of it, because making it so when I'm running this report, somebody who's changing that data has their information showing up in my report while the report is running is tricky. And it's going to bring us to our happy new little architecture here. So now we have our domain objects on the left-hand side. This is going to our data storage, and then we have events that go through a pipeline. They come over to this thing called a denormalizer, which technically is an anti-corruption layer, which then writes to our data storage. Our thin read layer then queries this data storage. Now remember, this denormalizer and thin read layer, I can make 10 or 20 copies of these. Just put a load balancer on top and we're done. My domain is what I really worry about in terms of scalability issues and things along those lines, because it's processing the transactions. I can have as many of these data storage read layers that I want. I could literally have 20 of these. It's no problem whatsoever. The entire right-hand side of this picture is horizontally scalable. It's the left-hand side that we have to talk about for scalability issues. And for most systems, this is not where your scaling problems are. For most systems, Reads are where your scaling problems actually exist. So now let's come back to commands, because we talked about queries quite a bit. Number one thing in your domain model, if you have getters and setters, you screwed up. I'm not going to call them an anti-pattern, you just screwed up. There should not be setters on domain objects. They should not exist. You should only have behaviors on your domain objects. You know, they are doing that whole object-oriented thing. Last I heard, object-oriented wasn't set foo. You're just exposing state at that point. You're a structure, not an object. Domain objects should have no setters on them. And okay, I know I'm being a bit extreme. There are some cases where it is actually kind of convenient to drop in a setter here and there. And you know, I'd be happy to look over that one particular case with you. But as a rule, there should be no setters. Now this interface actually came from a real system. And I want you to look at it really close on your computer screen there. How many behaviors are on it? Zero. Literally, there are no behaviors on that entire interface. It's defining a structure, which really begs a good question. Why on earth are we defining an interface for a structure? Why not just use the structure as the interface since, well, it's a structure? There's absolutely no value to providing an interface of a structure. There is no behavior on this entire thing. Everything here is structural, not behavioral. And this is what we're trying to avoid. And it's not at all uncommon to see an interface in these style of models where you have 75 methods on it. That's not what we want. If we were to be really, really careful, we might say these 4 things are behaviors inside of here. But even those are questionable behaviors. But this is what we want to see, is small interfaces with a few behavioral methods on them. We do not want to see 75 pieces of structure on our interface. And this brings us to bounded contexts. Now, how should bounded contexts be interacting between each other? Well, how many people here have read domain-driven design and how languages work between different contexts? And what if between my context and your context, you would agree that there were facts that happened in my context? And you could interpret those facts however you wanted in your context. Could I listen to Adam's events and have my own read model of what his events mean to me? I could query my own read model of what his events mean to me? Does Adam need to understand how I perceive his events? Or does Adam just put out the events that he's actually interested in from his own models? Who does the work, my team or his team? His team exposes the events. My team builds out our interpretation of his events. You have to admit, there's a very, very nice line there. We've delineated who's responsible for what here. And Adam deals with his software, we deal with our software. Now, there are some times where a certain read model might be used by lots and lots of different teams, things along those lines. So Adam might actually want to build it and provide it to people so they can just pull it down and, oh, cool, we got this thing already. That's really nice. Thanks, Adam. But we have very clear delineations of things. And when we talk about between multiple bounded contexts, as we were, it's almost assured that we can interact with relaxed consistency. It's not guaranteed, but it's almost always assured. We can use eventual consistency between things, which means we can have events being shipped back and forth. We don't need to have one transaction to rule the organization. Hold on, let me start up this transaction over here and get these 19 other services involved with it so that we can all put it through together normally until it doesn't work, and then we'll still say that we did it together even though we didn't. When we start looking at these kinds of bits of eventual consistency, what we really need to be focusing on is time in SLAs. And everyone likes to talk about their 99th percentile SLA, and we need to focus on this. Most of the time, we need to focus on what is our normal case. Is our normal case good? When we have a failure, what are our recovery strategies? And most importantly, when should we be focused on raising something that this might be an issue? Does not guarantee it's an issue, it might be an issue. And keep in mind with everything that we're talking about here, and it does add a little bit of complexity to relax our consistency, but we're going to gain both scalability and availability from it. Think back to CAP theorem. We're dropping a bit on our consistency, but we're going AP. So we're getting availability and partition tolerance. We can be consistent when we need to, and we can opt in for it. But by default, we're falling back to AP. It's not that we always use AP. And this will get you pretty far in terms of scalability and availability. You should be able to build a system that will not go down, ever, if you try hard enough. I'll just skip by that one. Just to summarize very quickly, state transitions are an important part of our problem space and should be modeled within our domain. These are also called events. You do not necessarily need to call them events. You can call them state transitions if you prefer, but I prefer the term events. If you see setters in particular in your domain model, that's a code smell. Be prepared to delete them. You are not modeling behavioral things in your domain. Getters are a lot more questionable. If you see lots of getters, that's probably a smell. If you see a getter sprinkled here or there, it's probably not the end of the world. This is more one of those things, if you see 1,000 of them, it's an issue. If you see 10 of them, it's not an issue. And here I say most bounded contexts can interact with relaxed consistency. Most here is an overstatement. It's practically all can interact with relaxed consistency, although you may run into some circumstances where it becomes problematic. These circumstances are fairly rare. And if there's one thing I want people to take away from all of this, regardless of if you even look at using event sourcing or something like that, it's that a single model will never be appropriate for reporting, searching, your transactional behaviors, all the things that your system is doing. Your single model is going to suck. As a rule of thumb, your single model is not going to be good at all of those things. There's a reason why you model first normal form, and there's a reason why you model third normal form. Some of those reasons are mutually exclusive, where if you've picked third normal form, it will not work well for things that you want first normal form for. Just how it works. What you should be focused on is, can I have multiple models as opposed to trying to find the exact right trade-offs in the one model that I do have? Having multiple models allows me to specialize my models for the different parts of the problem. This can be highly valuable. I'll ask if anybody has any questions. I'm not sure how the stupid question answer thing works on.
We can. There's few people here, so I don't think it'll be a problem if people just unmute themselves, and if they're polite, then we should be fine. So I'll assume that people will have their questions. Either they can, if you're shy, you can type them up and in the chat, and I'll read them.
Oh yeah, I see the chat.
Yeah,
You
you can type
now.
them up. There's a bit of questions about AP and CAP theorem.
Ooh, there's a good one here that I want to get to first.
Go for it.
Do you have to save code with the log? Well, maybe. There are times that you might want to actually keep your version code, which, by the way, how many people here are using Git, which oddly puts your code in the log? There are times where I might actually want to put the version of the code into the thing that's being produced. So when I write an event, I might actually want to say this is version 3.753A of the software when I do that. Why? It's not so much when I'm running a simple service with 1 or 2 instances of it. Think about when I'm running 800 instances, and we might have 5 concurrent versions of software running through them. So it broke. Okay, what broke? Which node was it on? It was on node 137. Yeah, when did that happen? Yesterday. What version of this software is that? I have no idea. So it's quite common that you might want to actually provide the version of the software on the event itself. Let's just see here. Do we have other questions?
So, Greg, I have a question for you then. All right. The question in a nutshell is are blockchain technologies, in particular distributed DALTs, are they a good alternative for application developers who need to move away from SQL databases but don't have all of this knowledge about distributed systems?
Oh boy. What are you building? I mean, for most things, obviously, just a linearized log is going to be infinitely simpler.
KYC type supply chain systems that need to verify the customer before they give out the cash.
That could probably justify coming onto something like a blockchain. For the vast number of things that people are building, blockchain would just be added complexity without much value. The real question is when we start talking about whether or not we want to distribute transactions, or whether we want to have essentially an arbiter of our transactions. In other words, let's think about banking. When I run my credit card, it goes to my bank, correct? I could build a distributed credit card processing system that would allow any bank to be able to process it via blockchain, and this would be awesome for availability. But it would also be more complex. It's not that one is right and the other is wrong. It's that they have different levels of complexity associated with them. And are you really getting value from the complexity that was added?
It's a good succinct answer, the arbiters. Thank you.